Hi everyone, it's Emma Boudreau here, and today I'm going to be going over the final part of the Charles Law project. So right here I have the question of, on a warm day, the air inside of a car has a volume of 40.0 liters and at a temperature of 310 degrees Kelvin. Overnight the temperature drops to 275 degrees Kelvin. So assuming the pressure inside the tire stays constant and no air escapes, what would be the new volume of air in the morning? So how is this question relevant to our topic? It is relevant to our topic of Charles' law because this law describes the direct relationship between volume and gas at a constant pressure, and this states how a gas's volume changes directly with temperature. And this question can be used in everyday life with the tire expansion in the summer. And although behavior of the volume in the tire is nearly fixed, the behavior of the gas still follows Charles' law. So I will be asking, why is this question important to understand? How does it benefit? So this helps in understanding when the temperature drops, gas molecules move slower, and gas takes up less volume and exerts less pressure. And this also can explain why a tire pressure decreases in cooler weather and why a driver's tire pressure light may be on. And in warm weather, the tire pressure will increase, or the volume will increase due to higher gas volume from heating. And this helps drivers be aware, making sure to check their tire pressure, notice if your light comes on, and air tires when the seasons change. And so this helps you understand when temperatures are hot, the gases will expand, and when temperatures are cold, the gas will contract. So how is this question different and unique? So this question is different and unique because it uses a practical situation and it ties physics to everyday life. And it's also different because the volume doesn't change much and can also be an opening door for follow-up questions like, should we be talking about pressure instead of volume? So I will explain why we're talking about volume instead of pressure. And is this question too easy or difficult to solve? How is it solvable? So using the given numbers of 40 liters of air, the temperatures of 310 degrees Kelvin and the drop into 275 degrees Kelvin, these numbers can easily be plugged into the equation. The first volume is already given, but this question is talking about the second volume. So a further explanation on this. So this question does have some easier numbers to calculate. We have the givens of the first volume, 40.0 liters, the temperatures of 310 and 275 degrees Kelvin. And to solve this problem, you would just need to use easy multiplication and division. And this question, it shows the relationship between temperature and volume and how you can plug these into the equation. And the math is not too difficult, even for those who can be troubled with math problems. And it can be interesting to car owners who have their tire pressure light turn on and off, and this explains why it occurs. And in here I added a picture of the gas molecules, how they move faster in the heat and slower in cooler weather. So down here I made a line graph, and it shows the relationship. It shows the increase in volume when there's an increase in temperature. It shows it increasing on the graph. And I also have the formula of Charles' law, and volume is, the V is for volume and the T is for temperature in Kelvin. So some relevant formulas for this question. So the formula is V1 over T1 equals V2 over T2. So V1 is your initial volume, T1 is your initial temperature in Kelvin, V2 is your final volume, T2 is your final temperature in Kelvin. It is always in Kelvin for temperature on these. So how do you solve this question? So the formula of V1 over T1 equals V2 over T2. So you plug the given numbers in, so it would be 40.0 over 310 equals V2, our unknown, over 275. So you're going to solve for V2. So using the numbers you plugged in, you would multiply 40.0 by 275 and divide by 310. So the last step, so V2 equals 11,000 over 310. You divide 11,000 by 310, and it is close to 35.48 liters, and you round the final number. So the new volume of air in the morning is approximately 35.5 liters. How is this solution correct? So the final answer is 35.5. The solution shows when air cools overnight, its temperature drops, and since gas molecules move slower in the cold, they exert less outward force and this volume will decrease. Charles' law states that for a fixed amount of gas at a constant pressure, the volume is directly proportional to its temperature in Kelvin. So when pressure stays constant like this, the question and the temperature changes, the volume will change proportionally, and the math is also correct if you calculate it like using a calculator, and it shows a connection between the temperature and tire behavior. So to wrap this up, we're going to talk more about Charles' law and the temperature. It must be in Kelvin in order to get the correct answers for solving anything using Charles' law. And what are some surprising things that we discovered during this research of Charles' law is that we use this in everyday life. Some examples include why the tire pressure light comes on when the temperatures drop, and it's used in a respiratory system in every single human by causing the inhaled air to expand and increase its volume as it warms the temperature in someone's lungs, and why a balloon will expand with warmer air and the gases will contract in it in cooler air. And just a quick summary of Charles' law. So the formula for this law is V1 over T1 equals V2 over T2. And this principle can apply to many real-world situations like hot air balloons, them rising, the car tire pressure changing with temperature, scuba tank buoyancy, differences in warm versus cooler water. In a continued summary, so our group worked together to create a presentation over Charles' law, and we were able to add in graphs. It went well, data, images, visualize and clarify how the law works. And what was difficult was making sure these questions weren't too simple or different and finding various examples of historical data to expand throughout the presentation. We have our list of sources for this project, and that is all. Thank you.